Hi everybody, welcome to your Unit 3 review, Exponent Rules. Okay, so this video will be on your review lesson and on your test lesson at the end of Unit 3. So first off, just as a quick review, right, this is an example of a number that's taken to a certain power. So in this case, the number 2, that represents our base. We would call that our base, and that is what we multiply by each other. And then the exponent, or sometimes it's called a power, that tells us how many bases we need to multiply together. So in this case we could say 2 to the third power, okay? And what that would look like, in this case, that would be 2 times 2 times 2. My base is what I multiplied. My exponent is how many I multiplied together, okay? So I'm going to be doing some review questions, but not a whole lot. A lot of it I'm going to be referring to a document that I created that will be on your lesson intro page, but it's also on my message board. So if you don't have that, it is called Properties of Integer Exponents. And I highly encourage you to go get a copy of it. If you can print it off, awesome. If not, just save a copy to your computer or just pull it up each time. So for number 1 on your test, you need this, okay? So this is going to help you with number 1. So as long as you understand those vocab words, you'll do just fine. Number 2, what kinds of things do we use exponents for? So if you remember from live lesson especially, right, what kinds of things? We use them for very small numbers and very large numbers, okay? So it's an easier way for us to write down those values, because sometimes numbers can be so small they go way past the decimal point, or sometimes there's just so many place values, the number is so big that it's too hard for us to write all of those zeros or all of those place values on one sheet of paper, okay? So we use the exponents to help us. Number 3, use the powers chart. So like I said, it's on my message board and it's linked to the intro page. I'm not going to do an example problem for this one because if I do, it's just going to give it away, okay? So what I am going to do though is I'm going to share my screen though, so we can look at it together. Okay, so looking at this right here, properties of integer exponents. As a review, so the definition of an exponent, that's like what we already went over on the paper, all right? Product rule of exponents, what that tells us is that if my base is the same and I am multiplying them together, I can add the exponents together, okay? So just to help simplify it. With the quotient rule, let me zoom in a little bit here, hopefully you can see those. With the quotient rule, that tells me that when I'm dividing, right, every fraction is a division problem. So when I'm dividing and I have the same base, I can subtract the exponents. And then I have examples over there for you as well. The zero power rule. Any number taken to the 0 power equals 1. It doesn't matter what that base is. If it is taken to a power of 0, it's equal to 1. And I go over that in one of my previous videos on why that happens. Power rule of exponents. So again, this is when they are being, when there is a base taken to an exponent inside of a parentheses, and then that entire thing is taken to another exponent, you can multiply the exponents together. Okay, and then the last one, negative integer rule. If a number is taken to a negative exponent, you can pull it into the denominator and it will become positive. The same is true if it's already in the denominator and it's negative, pull it up into the numerator and it becomes positive. So you can put those back and forth to make them either positive or negative. Okay? So this document here is going to help you a ton on this test, so make sure that you utilize it, and you should be okay. Let me stop sharing that. All right, so that for number 3, that will help a lot. This next problem is going to help you on number 4 and number 5. Okay, number 5 just has a variable in it instead of a numerical value. All right, it has a letter in number 5. So this one says, though, what does 2 to the negative 4 power equal with a positive power? So this goes back to that negative integer rule of exponents. So if I have 2 to the negative 4, in order to make this negative 4 positive, I'm going to pull it into my denominator, and I'm going to say that this is the same thing as 1 over 2 to the 4th power. If I were to continue with that, I could say, and I believe in number 4, you do need to continue with it. This would be the same thing as like 1 over 2 times 2 times 2 times 2. Well, let's see, 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So this is the same thing as 1 over 16. Okay? So again, that'll help on number 4 and on number 5. On number 6, simplify the expression using rules for exponents. So there's 2 different things going on in this problem. One, I'm multiplying these together. Okay, and there's actually 2 different ways that you could go about solving this. All right, the first thing I noticed though is that my bases are the same, right? They're both the number 3. And according to the, I just want to make sure I get the name correct, product rule of exponents, what it tells me is that when I am multiplying 2 numbers together that are taken to different powers, but the bases are the same, I can add my exponents. So one thing that I could do for this is I could say this is the same thing as 3 to the 5 plus negative 2. Ooh, right? Put parentheses around there, make that look a little neater. Well, 5 plus negative 2, that's the same thing as 5 minus 2. Whenever there's an addition symbol right next to a negative symbol, it means to subtract. Did I just say that right? I think I said divide in there. I didn't mean to if I did. So then 5 minus 2 is 3. So this is the same thing as 3 to the 3rd power. Okay? The other option, and maybe you saw it differently, maybe you didn't see it the way I saw it. Maybe you thought, well, I've got that negative exponent right there. This is the same thing, we could say 3 to the 5th times 1 over 3 to the 2nd. Well, if I put that over 1, then that means I have 3 to the 5th over 3 to the 2nd. With the quotient rule, right, I'm dividing, but I have that same base. This is the same thing as being able to subtract the exponents. And look at that, I'm at the exact same place no matter which way I saw it. And I think that is one of the coolest things about math is that most of the time there's more than one way to get there, okay? Because the rules are always true. So there's 2 different ways that you could solve on number 6. Yours is just going to have different numbers. Okay, number 7, simplify. So doing the same thing. We're going to get this down to as small of a, or as simple of a problem as we can. 1, bases are the same, woohoo, right? There's 2 different things going on. 1, I'm multiplying in my numerator, right? So I'm going to solve that first, and then I'll be able to figure out the division portion. So because of the product rule, I can add my exponents because those bases are the same. So this is the same thing as saying x to the 7 plus 2 over x to the 3rd. Well, 7 plus 2 gets me x to the 9th over x to the 3rd. according to the quotient rule, I can subtract my exponents in this case. So this is the same thing as x to the 9 minus 3. Well, 9 minus 3 is 6. So this whole thing is the same thing as x to the 6th power. Okay? All right, the last four, I'm not going into detail. Okay? Not going into detail because, again, if I were to, I would just be giving you answers, and I can't do that. So use that chart. If you haven't figured out where the copy of the chart is, go get it right now. All right? You need it for number 8. You're going to need the zero, the zero power rule of exponents. Okay? That's on the chart. Number 9. Look at what types of exponents you have and find those rules on the chart. So it's going to ask you, right, which rules would you use to solve? You need to pick the right ones. Number 10, you're going to make your own problem. So again, that's up to you. Go ahead and make your own problem, like the ones that you've seen in all of your different lessons. And then number 11 also requires you to understand the zero rule. All right, so I hope that helps. That chart, I think, will be a huge benefit to you. And as always, if you need more, just let me know.